So in this playlist, I'm going to do Hugging Face's course on image generation, which is this diffusion course. So last time I had finished NLP course by Hugging Face. It talks very nicely about how we can do natural language processing problem solving using the library Hugging Face has created. So NLP is one domain of deep learning language, and then image is the other domain. So this is the diffusion course. So by when you know both of them, you actually know almost everything in the landscape of deep learning. So these are the essential things to master. So let's go into the diffusion course. Okay. So first is the introduction to diffusion model. And these terms are actually so popular that nobody explains the intuition behind them. I faced the same problem when I was doing NLP. There were just words being thrown randomly, and the choice of the name was actually so bad that it was very difficult to understand what it was doing. The same thing continues here as well. So, if you want to understand, I recommend you focus on code, do the code, do hands-on, see how it interacts, and check out all the things you can check via code, and then build conceptual understanding. Do not rely on the terms which deep learning field has, the jargons which are part of this. You have to translate that jargon into a language you understand. It's like when we are teaching our friend, the language we use is very casual. The casual language is because we actually understand that topic so well that we can simplify it into our mother tongue or the language we are speaking with our friend. We want to translate the deep learning terms into those terms as if how we would teach our friend. So maybe Hindi, I think, most of my audience is in from India. So maybe Hindi, I think you'll find it a lot better if you translate it. Okay. So do that, and then it is a great starting point. So let's start with this. What are diffusion models? So the code you can find here on my GitHub repository. I have created a Hugging Face image generation course repository, and I'm going through unit number 1. Okay. Unit number 1 is Introduction to Diffusion Models. So what are diffusion models is what it was talking about. So diffusion models are nothing but ways of generating images. That's it. Midjourney, I'm sure you would know, or ChatGPT, I'm sure everybody knows. So in Midjourney, where we can use text and we give text as an input and ask the Midjourney model to actually create a image. So for example, I had given a prompt to render Harry Potter. So when Harry blows up his Aunt March and he's running away, so this was the image generated by Midjourney for me, and this looks pretty nice. The lost feeling of Harry is captured. How and the maybe the atmosphere is not that dark; it's a bit bright, but it really captures the theme. So this is image generation based on text. So what diffusion models are is it is nothing but just one of the ways of generating images. There are so many applications of image generation. If you decide a use case which is tied to a real problem, and if you can sell that solution to that problem, you have a valid business case, right? Do not focus on just generating images for image generation sake. Tie it to a problem, and diffusion is just one of the ways of doing that. There are 3 to 4 existing approaches of image generation. First is variational autoencoders, so it's called as VAEs. Then there is another approach which is GANs, generative adversarial networks. And then there is another thing called as denoising diffusion probabilistic models. So, as you would have noticed in the words I use now, none of them make sense. Okay, what is VAE? What is variational autoencoder? What the fuck is generative adversarial networks? Or what is denoising? Diffusion, publicistic. It's just words, and when you understand what they're doing, it is a lot easier. That's why I had asked you to translate it in the language you can understand. So let me translate in a language I understand. VAE is an architecture in which what it does is it takes an image, compresses it. It compresses. Because if you take a photo, okay, let's say this is the video you're watching right now, you want to compress it. There are so much white here. This each pixel value is taking a lot of storage, right? So if we can compress this 1080p video thing into a smaller thing, it's a lot easier to store, right? So we compress it, and from that compressed representation of an image, if we can decompress the original image back again, that is encoder decoder architecture. So the word again is complicated, but it's simply compress the image, and from that compression recreate the image. That is VA. What is generative adversarial network? In a words we can understand, what it does is like there is an image generator and there is a fake image generator. Okay. And we specify the network in such a way that I want to ensure this fake guy learns in such a way that he can fake well. It's like we are training that neural network to do forgery, and we reward it when it does a forgery accurately. And because we are rewarding the forgery quality, what happens is eventually it learns to create images which look very much like the images we have given to the model. And then what is denoising diffusion probabilistic model? Internally, we are using what we are doing is this. Let's say we have a noisy image. If we can recreate the original non-noisy image from it, it is good. We do that in incremental ways. So instead of just one step denoise, we do that, 10 steps, let's say. So that is 10-step denoising from a highly noisy image to a high quality image. And this, the way this is like a decoding thing, like in variational autoencoders we talked about. So what you do is you add noise to image. Eventually the model learns, oh, it learns to denoise it. Why did we add noise? So that we can learn to denoise. So we added the noise ourselves, all because of learning to denoise. And so when we can denoise a image, we can also kind of like create different images, because from a denoising thing, there are multiple options possible of image generation. And this is what happens in this such image diffusion models. So this is the Harry Potter ones I was creating. So this is also a very good image which was created. So what it is doing is for each and every pixel here, it starts. Oh, you would love this. So let me do very strong here and pay strict attention. Just a second. Huh? Pay attention to the images which are being generated here. Okay, at the bottom part. There is nothing coming here. I'm just shocked. Okay, yes. So you see, this is a noisy image with some approximate representation of what we need. If you slow down how the image is being generated, what it does is in broad strokes, it captures essential things we asked. The first instance of the four blocks which was created, it contained simply a lone figure. That's all it had. And iteratively, we added the rest of the details to that. So, from a noisy image, we removed the noise in such a way that what remains is what we want. And iteratively, over time, it kind of like keeps doing this. That is what is happening. So pay attention to how this thing is changing. It starts with a very blocky and vague image, and noise is removed in such a way that we get the answer we want. That is denoising probabilistic models. Okay. So these terms are chaotic, but in internally what it is doing is it's simply generating images. There have only been three major architectures which can generate such images. There are many more possibilities. Don't be limited just by these. Most people focus, they never think beyond this, but I really ask, implore you to actually think about what are the different approaches you can think of. And if you can think of, any other approaches, you will understand these three approaches a lot better. You should know these strengths. You should know these guys' weaknesses. You should know if the solution you have provided as an alternative to them how is it compared to these three. So now, if you know this, you know image generation in a lot more depth than everyone else. You won't be just someone who is replicating, what Mid Journey can already do. That's why we need, convert it into a language we understand, then build on it, try to find out alternatives. That's how we should go about, studying diffusion thing. So that that's our thing. So diffusion course is focusing on just the diffusion model. So we don't go into GANs, we don't go into VAs, we just go into diffusion. And the core diffusion thing has three main components. You have a pipeline, you have a model, and you have a scheduler. Deep learning is a very interesting field. The essential pieces which are always used no matter what type of solution or no matter what type of problems, they are very few. You will find these models repeat again and again. You will find ResNet repeats again and again. You will find UNit repeats again and again. You will find transformer repeats again and again. So master these fundamental things and you can apply them anywhere. Okay. So the core component is pipeline, model, and scheduler. The pipeline is part of this library diffusers. Hugging Face has created this library where they have provided to us all of these things in one shot. We do not need to write the code. We can directly follow the same approach the Hugging Face thing has done for NLP. If you pay attention here, this looks very much like how we do it in NLP from pre-trained. So in diffusers library, there is this DMPM pipeline, denoising diffusion probabilistic model. Again, such a complex name. So from pre-trained, and what this it is doing is it was trained on images of butterflies, and we are hoping that it generates images for us. So this is the from pipeline, and butterfly pipeline we have, and batch size equal to 8. And when we say this, this has generated these 8 butterflies. So one of the ways of generating images. Now, better we can do this, higher quality of our image generation model. Midjourney is doing exactly this, but it is doing that a lot better, right? So pipeline, model, scheduler. Pipeline is denoising DDPM pipeline. Okay. And if you want to train it, it goes on the data set. So again, if you pay attention to this code, you will find it is very similar to what you have done until now for NLP. Okay. So it's all part of the same thing. So having pipeline, then having model, then having scheduler, and then taking these all three and making sure that we train the model. So this is training of the model. These are all things you have seen until now. Okay, we know how to train a neural network. I hope you know. If not, you can go to Kaggle Learn and they have an excellent course. You can master the fundamentals from there. So the same fundamental of neural network with a model and a model being trained, all of the same thing just tweaked in a bit way, we get a generative image network. So, I have just introduced how this whole thing goes. And in next video, we will go into in more detail of this internal pipeline and we'll learn diffusion models into more detail.